Good afternoon. Welcome to Flagstaff Steel bid presentation. The Northern Arizona University International Pavilion is a two-story, 8,000 square foot educational building. The metal scope of work for International Pavilion includes miscellaneous metals, metal studs, structural framing joists, and metal decking. Flagstaff Steels will be quoting all of the structural steel and miscellaneous steels. We will be providing and installing all the quoted material unless noted otherwise. We project a duration of 55 days for steel installation. We look forward to having a successful project.
The scope of work for the project is steel joist framing, steel decking, and structural steel. The steel joist framing covers all of the 18K, 28, and 14K beams. The steel decking covers all of the project, and then the structural steel involves W-shaped beams, W-shaped columns, and HSS columns. For the International Pavilion on NAU campus, there will be a designated mobile crane path, lay-down yard, entrance, and exit for steel personnel. The entrance is on this side of the job site, and the exit goes on to this side, and there's a second path up here on the campus headway. The mobile crane will be placed on the south and southwest section of the job site. The crane will be allowed to move between these two locations. The crane will pick up from the designated lay-down yard in this parking lot next to the job site. The entrance will be off of East Runk Drive into lot P32B2, which is the parking lot next to the job site, and the exit will be down here. Due to the large crane radius, there will be close-offs on the job site from the campus headway, so that's why we can have a second exit for deliveries. While the steel is being erected, temporary horizontal and vertical bracing and supports to secure the framing will be installed. This will help to support the loads during the erection process. The braces and supports will remain undisturbed until the entire supporting structure has been completed and the structure is secured.
My name is Camilo and I'm the Senior Project Manager. The directions: our warehouse of the steel is located in 5055 Kenmore Drive, and the steel trucks will drive around campus, taking the McConnell Drive and then turn onto Sawmills Drive. Our traffic control. To prevent any traffic jam and to be sure that trucks will have enough turning radius, all the deliveries will make between the 7 a.m. and 8 a.m. In this way, the campus stands routine will not be affected, and our trucks and crane will not have any problem delivering or placing in position in the site location.
The schedule follows a design-build process and totals at 55 days for all the steel. It starts out with creating plans, specs, and contracts before the construction phase, and then going straight into submittals. The submittals are broken down into steel decking, steel joist framing, and then metal fabrication, which all needed their own specific certification, like LEED, field quality control, welding certifications, etc. Each certification will be crafted at the same time as each shop drawing to reduce the total duration. For example, once the plans are approved, every shop drawing and certificate is started at the same time in each section of the steel. Once everything is approved, the bidding process is underway, awarding a GC so that procurement can start. For the procurement process, it will take a few days to contact and deliver to the fabricator and 17 days to have the steel manufactured after receiving the order. Before the erection, it will take a week or two to rent the crane equipment, hire all laborers, equipment operators, and create a site logistics plan based off of the site with all the included facilities. To stay on a tight scheduled delivery will be done with many trucks delivering each section of the material in one day for the columns, joists the next day, and girders in the third, all stacked up in the steel laydown area. The erection durations are based off of averaging around 2 weeks per sequence. Once each composite floor, deck, / sequence is done, the bracing team will come in and work on that floor as the steel erection team works above them to try and complete this project in a 2-month span. Once the erection is finished, the roof deck may be installed, and based off of RS means with a good crew, it should only take 2 days to place. Now our project is complete after closeout.
So the total cost for the project, as you can see, is $215,970. It is divided in the structural steel. The total cost of this part is $161,000 with $157. The joist, the open wall joist, costs a total of $13,823, and the metal deck, its final cost is $14,989.
The takeoff for the beams were done by taking the lineages of each beam and then categorizing it into its own amount of tonnage by using the given amount of pounds per foot on the W beams, or using the steel construction manual to get the amount of pounds per foot on the K joists. So the majority of the 14K joists are on this side of the building, while the lower half of the building is broken into the 18Ks or the W beams up higher. The top part of the job is done by the LH, is constructed with mostly 28 LH beams and joists.
For the takeoff for the metal decking, as you can see, this is the composite roof deck. It stretches the entire length of the roof, and this is the floor deck. The roof deck is 7,678 square feet. We do not use cubic yards for this, and the floor deck is 2,460.
For the takeoff for the beams and the steel columns, first, for the steel columns, we divided each in 3 floors. First floor, the second floor, and the roof. So, then we divided for the type of beam. As you can see, we have W and HSS shapes. We take the linear footage of each one, multiply by the height of each floor, then we got the total length, and with the weight of each beam, of each column, we got the total weight for each roof and for each level, sorry. For the steel beam and girders, the procedure was almost the same. We divided it in second floor and roof, and then the next division was the type of beam, the shape, and we have the quantities and each size. As you can see, we multiply both to have the linear footage, and then we multiply it by its weight. And the last part for the roof, as I said it before, we have the same types. And here is the total beam weight that we calculate. For the angles, the angles are in each beam, so we measure the length of each beam, then we divide it by 48 inches, that it was the off-center distance between each angle, having a total of 124 angles. We took the deepest beam measure, as it was set in one of requests for information. Then for the length of each angle, we look at the structural plans. We got that one side was 1.5 feet, the other side, that was the beam, the depth of the beam was 21, and we got the total length of each angle. The weight, we look it in our structural plans, and then we just multiply the total length by the number of angles.